There are so many issues that humanity needs to solve. Climate change, poverty, disease. We always seem to be demanding more resources to solve these issues. More food, more water, more money. One resource this generation seems to have too much of is data, and by using this data, computers are now driving cars, outperforming doctors in cancer diagnosis, and even beating us at our own games. How is this happening? The answer is deep learning, a powerful breakthrough in artificial intelligence that has the potential to impact hundreds of industries and billions of people. At the core of deep learning are neural networks. A neural network is a mathematical representation of our brains, capable of replicating our cognitive functions such as problem solving, pattern recognition, and our ability to learn. Like the brain, neural networks are made up of many layers of neurons that are connected through synapses called weighted connections. Each neuron is a function that takes in inputs, and based off of the weight, it determines how it's going to affect the output. Larger weights contribute more, and smaller weights contribute less. Finding the right weights allows the network to recognize complicated patterns that humans could never see. Let's look at a simple neural network that predicts if an animal is a dog based off of the features you tell it. Like all neural networks, it has three main types of layers. An input layer to feed in the animal's features, a hidden layer where the network processes the calculations, and an output layer that returns an answer. By changing the weights that connect each layer, our network can learn what features make a dog. Obviously, dogs don't have feathers, so this connection has a negative weight. Likewise, dogs do have four legs, so this connection has a positive weight. By simply estimating the weights, we created a simple three-layer network that can recognize dogs fairly well. However, for more complicated problems, we require deeper networks with many hidden layers and thousands of weights to assign. Instead of manually assigning values to the weights, neural networks can learn to find accurate weights on their own through a process called training. Just like how basketball players improve their aim through practice, neural networks optimize their weights through training. When you first learn to shoot a free throw, you have no idea what factors make up a good shot. Your goal is to minimize the distance your shot misses the basket by, and through practice, your throw gets more and more accurate. Neural networks also start off really inaccurate. That's because its weights were not trained yet, and it's guessing all of its predictions. The network's goal is to minimize the difference between what is predicted and the real answer through a cost function that tells us how inaccurate our network's predictions are. Initially, our cost is really high, but we can minimize the cost using gradient descent. Gradient descent helps the network learn how it should change its weights to reduce its cost. It can create a landscape of sloping hills and valleys, with mathematical gravity pulling our weights downwards to a lower cost. By using gradient descent over and over again, we minimize the cost of the network, increasing the accuracy, and eventually creating a neural network that is on par with humans. From understanding human speech to discovering new synthetic drugs, the applications for deep learning are endless. Even the music I used in this video was created using deep learning. 50 years ago, we never thought that self-driving cars were possible. Just imagine what the future of deep learning holds for humanity.